Thank you for coming to my talk. My name is Beatrice Alex. I'm from the University of Edinburgh, and this is joint work with John Burns, who used to be a director at JSTOR and is now retired and likes to get his hands dirty with real data, basically. So the work I'm presenting is on a project called Trading Consequences, and this is just the overview. I'll talk a bit about the project itself to give you an idea of the background, and then talk about OCR estimation and rating, why we want to do it, what's the related work, and what we did, basically. So Trading Consequences is a 2-year digging into data project, which involved 4 partners. Partners in the UK and in Canada. It finished at the end of last year, but the historians involved in the project are still continuing their work now using the tools that we created. So the main aim of the project was to combine text mining and data visualization to enable historians to access data in more efficient and interesting ways. And the domain is commodity trading in the 19th century, so a lot of our data is from that time period. And I already said that it's really to support historians. So this is the project team. There are people at Informatics at Edinburgh. Ewan Klein is the main professor. Then there are people at York University, Colin Coates and Andrew Watson, who are the historians, including as well as Jim Clifford, who moved from York to Saskatchewan, a university that I always found hard to pronounce. Then Edina is at Edinburgh as well, and St. Andrews, who are responsible for the visualization. So really the more traditional way the historians did their research in the domain that we are tackling is to look at a lot of documents and compile data by doing that, and then draw static maps like these, for example. So here we have the global fat supplies from 1894 to 98, and then another map for mahogany. And you can see that you can see where these commodities were important, but it's very static, and a lot of work went into this. The people had to read a lot of documents. So our project was to see how can we create this kind of information, but much more dynamic and for many more commodities at the same time. So this is just another overview of how we are all interlinked. So we are responsible mainly for the text mining, and we're creating this database, which is populated by Edina, which is now also available for research purposes. So the document collections that we're processing are mainly around the 19th century. The biggest one is from ProQuest, House of Commons Parliamentary Papers. We have documents from early Canadian Online, which was quite important for this project since we had historians from Canada involved. And then we have a few smaller collections. And I should say at this point that all of these data sets, we get them when they're already digitized, so we didn't do digitization first. Altogether, we processed 10 million document pages and over 7 billion word tokens. So this is not big data for computer scientists, but it's big data for computational linguists who have to worry about part-of-speech tags, tokens, lemmas, and all the other layers of information that come on top of it. OCR text. So we knew that we had to worry about the quality of the data that we got, since some of it was digitized 10, 15 years ago. So when we saw documents like this, we thought, oh dear. And then we saw documents like this and thought, oh, how can we make any sense of this? So we realized early on that we had to figure out a way of identifying the quality of the text that we're dealing with, and to see whether it made sense processing them in the first place, or whether there were some documents which were okay enough to post-correct. This is one that is the worst kind of case we had in our collection. In our collections, it's actually a document which was scanned upside down. So. And even I mean, I would challenge someone to actually turn it around and make it into readable text. So I've already motivated the reason why we've done this work that I'm presenting next. So it's really to identify what data is usable for mining purposes. We heard this morning that only 10% of data is digitized, and only of that a small percentage is available to use. So this is an even smaller percentage of text that is actually currently good enough to do something useful with automatically. So really what we wanted to answer is how does OCR quality affect mining, and what texts are sufficiently enough in terms of accuracy for us to pull out good information, and then what percentage is just so bad that it's potentially better to just ignore them from the mining point of view. And also whether humans can actually rank the quality of documents. So there's a little bit of related work in that area. We have some of the OCR engines are spitting out character-based accuracy rates, which are not always that easy to interpret, and are usually not useful for people like me who are working on the word level a lot of the times, or larger units. There's a paper by Poppard 2009 who did a very extensive study on ranking and estimating the quality of snippets in different languages. And what they've done is to order snippets in terms of kind of from lower to higher quality for five tuples. So you knew that you can easily identify whether or not one of the snippets is better or worse in quality than another. So it always depends on other snippets. And they compared an n-gram-based model, one that did kind of took the position of the characters on the page and also in the sequence to a dictionary approach, and found that the spatial n-gram model is performing relatively well compared to the other approaches in most of the languages. They compared random to balanced as in stratified sampling, and found stratified sampling led to a smaller to a higher inter-rater agreement. And their metric was average rank correlation. So as opposed to this work, we wanted to know how documents are rated independently, not dependent on other ones. So we did work just on estimating and rating documents independently. And we didn't want to spend a lot of time doing this. We didn't want to have a program that spends a lot of time calculating this kind of stuff, so we used a very simple approach, which was document level based. What we wanted to find out is, are OCR errors negligible when we are mining big data? Because the project that I'm involved in is looking really at global trends. So maybe the most frequent commodities and location mentions that we identified are good enough, and actually all of the OCR errors won't really affect our results. And we have, as I already showed you from the examples, typical character confusion errors insertions, deletions, and so on. But we also have documents which are a lot worse. So here's just some eyeballing of our output data. So we have a named entity recognizer which identifies location and commodity mentions. And so here are the OCR errors, cattle and cattle, where the E at the end is accidentally swapped to C, just over the Google Ngram corpus. And you can see that this is quite prominent at the beginning of the 19th century, and then it levels off. But when you compare that against the correct cattle, these errors disappear. I mean, it's just noise. So seeing that made us feel slightly more reassured that hopefully the stuff that we are pulling out is good enough. This is just another example for where the correct commodity is mahogany, and then here two spelling variations of OCR errors, and you could again see the quality, the frequency appearing on the Google Ngram corpus, and again against the correct spelling, they disappear pretty much. However, there are some cases where OCR errors lead to real-world commodities. So in the case of time, was in many occasions misrecognized as lime, and lime was at first one of the commodities that we were interested in. So this is an issue. So we basically looked at the context of several of hundreds of sentences containing lime, and found that actually in most cases it's actually referring to time or line. So we then had to take a different approach for that specific commodity. But really we wanted to do a more quantitative analysis and not just eyeball our data. So we took our recognizer and ran it over a test set, which we also manually annotated to create a gold standard, and then did some evaluation, and particularly wanted to do error analysis on the false negatives, so to see what makes our software perform badly in terms of recall. So we found that out of the 310 commodity mentions, like the gold mentions, 32% were actually OCR errors. Things like Sinon for salmon, rubber for rubber, and timber for timber. And then similarly for the locations, 32% of the false negatives contained OCR errors. You can see some examples for Montreal. Overall, the percentages are still really substantial in terms of how many OCR errors are contained in all of the gold standard. So there's 9.1% for the commodities and 14.8% for the locations, suggesting that possibly named entities are much more affected by these problems, presumably because some of the OCR engines are using language models and don't know a lot of the locations. And that's just the list of wrong false positives for Montreal in terms of frequency. So now we wanted to know whether we can somehow estimate test quality in a very simple way, because we had to do it for a lot of documents, and we still had to do all the research doing the text mining, so we didn't want to spend a year just improving the OCR. And we also want to know how well can human beings actually rate documents. So in terms of the automatic rating, we just applied a very simple metric, taking good word tokens, which we are defining as ones that are in the dictionary, as well as Roman and Arabic numbers over all tokens in the document. So the scores range between 0 and 1. There's there's no, it's not a very complicated metric. It's very simple, and it doesn't consider historic variance. Yet we hoped by doing that we could get some kind of idea of how good our documents are. So this is just how the score distributes over all of the early Canadiana online documents, for specifically the English ones. You can see that the score is quite high, around 93 to 98, and then goes down for quite a lot of the sort of a majority of the documents. Then we wanted to do some manual rating, and so we took the early Canadiana online documents, again, just the English ones. So there are 55,000, over 55,000 documents. And we asked then run our automatic score over all of those documents. I already showed you the distribution, and then took, through stratified sampling, 100 documents. So we took 20 documents for each kind of quality range, basically, to get a spread over the quality score, because we didn't want to get the same distribution as is in the collection. We wanted to see how well the lower score documents are ranked as well. And then we shuffled them and removed the score. And then we asked 2 people to look at each document and rate it on a 5-point scale from very high to very low. And there's a bit more detailed information on the annotation guidelines, which you can access on GitHub. So this is the inter-rater agreement. So we plot on the X and Y axis each of the raters. And you can see in purple where they agree, and in green where they are disagreeing. So 1 is low quality and 5 is high quality. So you can see that the raters are not very good at agreeing on the medium quality documents. And they also disagree on some of the differences between the 1 and 2 and 4 and 5. But they don't actually find it that difficult to decide what is good and what is bad. So the extremes are easy to rate, but the more fine-grained rating is quite hard. So what we then also, this is just a collapsed rating scale where the 1 and 2 are combined and the 4 and 5 are combined. And for this, the weighted kappa is 0.6, if anyone cares about scores like that. And that's just on the border between moderate and substantial agreement. So then we compared the human rating against our automatic scores. And you can see here that with the human rating from 1 to 5, and the automatic score between 0 and 1, when you plot those against each other, you can see like an upward trend, which is reassuring. This is the first rater, and then for the second rater, it looks relatively similar. Again, you can see that the spread for the medium rated documents is much higher. So the system also seems to have an issue with trying to, or the system and the rater also disagree a lot, which is probably because it's not as easy to get a real feel for how good a document is, for how good the entirety of a document is by just eyeballing parts of it. And then we looked at some outliers, and that's again, it's the two or three documents which both raters classed as very high, but which the system thought were very low, and we found that they also commented that these documents were very mixed. So it's possible that actually the quality, the in-dictionary words were much higher in places than in others. So what we really wanted to know now for our mining purposes is where do we apply a cutoff, and where is it? Is it at 0.7, where you can ensure that all of the high and good quality documents are considered and everything, more or less everything else is ignored? Or is it lower at 0.6, for example, where some of the lower quality documents make it through the system, but of course then also affect the results? So then we looked at how much of the corpus we actually throw away, because the historians we work with were really worried that we would throw away too many documents, and so they were really keen to see this graph. And you can see here by setting a threshold at 0.7, about 11% of the data gets ignored, and then lowering that kind of pushes more data into our pool, but also increases, decreases recall. So just to conclude, we applied a very simple quality scoring metric to very large document collections, and we can show that automatic and human ranking correlate. We found the document level rating isn't very easy to do manually, which isn't really that surprising. And in some ways, a machine is much better at doing that kind of task, because at least it can be consistent, even if the metric isn't necessarily ideal. We found that OCR errors don't always affect our results, specifically not for high-frequency terms. But we also found that when looking at their kind of quantity in total, it's not an insignificant amount, and it's really important to make humanities and social sciences scholars aware of that, because many of them don't realize how many OCR errors affect their searches and don't bring up documents which are there in the data. So in terms of future work, we are looking at the publication date and the digitization date when considering these estimations. We also want to look at the documents which are kind of worth correcting, and we are continuing this work with a new project which just started at the beginning of the year, which is called Palimpsest. It is on mining and georeferencing Edinburgh's literature. So literature set in Edinburgh, it's in collaboration with literature scholars who are really interested in place name in literature and its context, and that's funded by HRC. And I would like to thank you, but if I have a little bit of time left, okay, a minute, and I can just quickly at the end show you the result of the trading consequence project. Among other things, is an interface to the data, basically. So here we have one of the views for cinchona is one of the commodities in our list of almost 2,000, which is it's to do with it's a bark which was used to produce quinine to cure malaria, and so in the tool basically lets you go straight to the documents that this commodity was mentioned in, click on related commodities, so other ones that are kind of appearing in proximity to quinine in the text, and lets you visualize where exactly these commodities were relevant in terms of the map and also time. Okay, thank you.
Thank you. Now we have time for questions.
When you do your quality measure, which I think would first come to mind, so I'm very delighted that you have done this work, because I also would like to measure if I have 1 gigabyte of OCR text, what quality it is, and not only on the total text as a whole, but also split it in parts. Did you also apply a lexicon with historical forms, or are they so important because they have the ability to degrade your result, although it's maybe higher?
We didn't know. We just used a spell, so we just used the modern terms. So we should really spend a lot more time, including historical terms as well. You're right, but we didn't do that.
Did the human raters know what your criterion was for the automatic assessment?
What the score was? No.
Did you talk to them? What could be criteria for good or bad?
We just gave them the ranking with some additional text to it applied. Oh, I think this is further. We just gave them this ranking, including the text, and said we wanted 5 to be really good quality, even if it contained a few errors, because I don't think we actually have any document there that haven't got any errors in them. And 1 to be extremely low, and then the in-between scores as well. So, but they didn't know about the automatic scores when they did their ranking.
You also discussed a gold standard you used. I forget where exactly you used it, but is that available or going to be made available?
Sorry, is it what available?
You discussed a gold standard you used somewhere.
Yes, so we've got a list of the ratings, of the human ratings and the document IDs from Canadiana on GitHub. It's Dig Trade on GitHub. You can access it now.
Yeah, but is this a gold standard?
Yes.
Okay, that's
so
fine.
we didn't make them agree. The 2 people that rated the documents, we didn't ask them to agree on their rating. So we just have 2 separate ratings, basically, independent ratings.
Yeah, but these are ratings then. Perhaps I fully misunderstood you. Never mind, I'll talk to you.
But yes, you can download it, and it's the gold standard we used. So.
I liked your presentation very much, and I like how you verify that the document is very garbled. But my question is about the other thing that you presented. So, in your statistical experiment, you showed that 30% or 32, I don't remember, 30% of the false negatives recognize commodity. So it was commodity recognition. Mm-hmm. So 30%, we have 30% false negatives.
Yeah.
Okay, the question is, what will happen if we correct manually these 30% and then run the recognition again? So how, or in other words, how do you conclude from these 30% that they affect the recognition?
Yes.
The OCR errors affect the recognition, the commodity recognition.
Yes. So the numbers I've given is just the percentage.
Yeah, exactly.
Yeah, the percentages of false positives that contain OCR errors, and also the percentages of all commodities and the gold standard which contain those same errors, basically. So the 30% is or the 32% are the false positives related figures. And you're right, if we hand corrected, or first hand corrected probably the OCR errors in that text and then redone our recognition, then that would push up the scores. Potentially not by the entire amount, but probably a large majority of the cases. We didn't do that, but yes, you can.
Thank you.
Definitely, it's a good suggestion.
Other questions?
When I look at your criteria, where you rate the quality of OCR documents, when I look at your criteria for rating documents, I got the impression that they always assume that two distinct phenomena are closely interrelated. One is the problem that some of the OCR tokens are completely garbled and cannot be read anymore. And the other is the number of OCR errors. I think this depends much on the collection, if these two problems are really correlated. You might imagine documents where you have lots of OCR errors, but they are all not really serious. Serious in the sense that words get completely unreadable. And sometimes you also meet pages, for example, with some geographical notions or lines or etc., or distinct fonts, where parts of the text are completely destroyed and others are completely readable. And I would say that there's room for refinement of your quality criteria under this aspect.
Thank you. That's very useful. So you're right. There were especially the documents that were ranked in the medium, the mediocre ones. A lot of them were very mixed. So you would get one page that was actually not too bad, and then the next page was completely crazy and garbled, like you were saying. So that's the reason why they were the human raters disagreed as much on that category. Yeah.
Okay, thank you very much.